In this video, we will continue practicing solving equations like this one, trig equations. Now, throughout this video, I am going to assume that you have the information on this chart basically memorized, or at the very least, you should be able to take out a sheet of scratch paper and generate this chart within a minute and a half. So, the key is to get the trig function by itself. So as I look at this, I'm thinking to myself, I need to get sine 2x by itself. I'm going to add 1 to both sides. So that'll give me radical 2 sine 2x is equal to 1. Continuing to get sine 2x by itself, now it is time to divide both sides by radical 2. That'll cancel these out. Now I have sine 2x is equal to 1 over radical 2. Notice that I cannot divide by 2 to get rid of this 2. It's inside of the trig function. You cannot divide it away. Instead, we're going to go ahead and just solve the trig function for 2x. So the sine of what angle is equal to 1 over radical 2? So we know that the sine of pi over 4 is 1 over radical 2. That tells us the reference angle. All right, so the reference angle is definitely going to be pi over 4. So that allows us to draw the correct diagram. There's pi over 2, here's pi over 4. Okay, so these are pi over 4s. The reference angle appears in these 4 places. All right, all 4 of these angles have a reference angle of pi over 4. The sine of all 4 of these angles is some kind of 1 over radical 2. But since sine is a y value on the unit circle, the sine of these 2 angles will be positive, and the sine of these 2 angles will be negative. In this case, we want a positive 1 over radical 2, so that means that these 2 angles will be where we find our solutions. Now, normally we would just say x is equal to this, x is equal to that. But we don't have x, we have 2x. So that's what we have solved for so far. We have solved for 2x. So 2x is equal to pi over 4, or 2x is equal to this. And this is 1 pi over 4, 2 pi over 4, 3 pi over 4. So either 2x equals pi over 4 or 2x equals 3 pi over 4. Now, of course, we want to actually solve for x. So in order to do that, now we will divide by 2. So I'm going to divide both sides by 2. Now, when you divide a fraction by another number, what you can do is just put that number in the denominator. Okay, so what I like to do is, let me just erase this. When I divide by 2, that 2 just joins into the denominator. And I'll do the same thing here. When I divide by 2, I'll just put it here in the denominator, and boom, I'm dividing by 2. So that's going to give me x is equal to pi over 8, or x is equal to 3 pi over 8. And that's it. Those are the 2 solutions to this equation. Okay, let's keep going. All right. So, oh yeah, by the way, there are infinitely many solutions if you go around and around the unit circle, but we are limiting our answers to the solutions between 0 and 2 pi. So 1 lap around the unit circle. So what will I do? So let's start off by getting sine squared theta by itself. So I'm going to add 1 to both sides. So that's going to give me sine squared theta is equal to 1. To unsquare this, I need to take the square root of both sides. Now when you take the square root of both sides, the solution could be positive or negative. So do not forget your plus or minus, or you will be missing half of your solutions. So this unsquares things, so that means that sine theta is going to equal positive or negative 1. So at what angle will that be true? Well, this is probably best to look at if you just sort of draw the unit circle. Remember that sine is a y value on the unit circle. So for example, this point right here is the point 0, 1. And this point is the point 1, 0. This is the point negative 1, 0. And this is the point 0, negative 1. Now focus on the y values. All right, we want the angle or angles that will give us a sign of positive or negative 1. That means a y value of positive or negative 1. So that's 0, so nah. Well, there's positive 1, that's 0, nah, and there's negative 1. So these two angles are solutions because they will give us positive or negative 1. All right, so what are these angles? Of course, this angle at the top here is pi over 2. And the one at the bottom is 3 pi over 2. All right, so those are the two solutions to this equation. And hey, you know what? I'm going to do one extra step. I don't do this often, but I'm going to check one of these answers just to show you what's happening here. If these are solutions to this original equation, of course that means that if I substitute them back into the equation, it should make a true statement. So let's check this one, for example. Let's check the solution 3 pi over 2. If I substitute that back in, and I'm just going to write check. If I substitute that back in, that would give me sine squared 3 pi over 2 minus 1 is equal to 0. Okay, well, what is the sine of 3 pi over 2? Well, the sine of 3 pi over 2 is negative 1. All right, so there's my negative 1. Now this is sine squared, so this will be negative 1 squared. And of course, negative 1 squared is positive 1. So that gives us 1 minus 1, which does in fact equal 0. So that is what is happening. It checks out. All right, anyway, let's keep going. Well, this one, the sine, the trig function is already by itself. You cannot divide by 3 to get rid of this 3. Instead, let's just look at the solutions for 3 theta. In other words, look, the sine of what is equal to negative 1? Well, we can just use the picture from before. Sine is a y value. So what angle on the unit circle has a y value of negative 1? There's only one, 3 pi over 2. It's right here. So the answer to the question sine of what is equal to negative 1, that question mark is equal to 3 pi over 2. Okay, but look at what is in the position of the question mark. 3 theta. So when we are solving this and we're asking ourselves, okay, the sine of what is equal to negative 1, when we figure out that that has to be 3 pi over 2, then that means we have just discovered that 3 theta must equal 3 pi over 2. Now we can divide both sides by 3. Remember, when you divide a fraction by a number, just put it in the denominator and then boom, there you've divided the fraction. So those cancel out, and that's going to give me theta is equal to 3 pi over 6. Oh, that reduces, so that's theta is equal to pi over 2. All right, number 9. First, we need to get cosine squared x by itself. So let's add 3 to both sides. So that's going to give me 4 cosine squared x is equal to 3. To get cosine squared x by itself, now it's time to divide both sides by 4. So let's do that. 4's cancel out. That tells us that cosine squared x is equal to 3/4. To unsquare this, we're going to take the square root of both sides. Please remember that when you take the square root of both sides, your solution will be either positive or negative. 2 solutions. So, cosine squared x, sorry, we took the square root, so now it's just cosine x equals plus or minus the square root of 3 over 2. Remember what I just did there. If the square root of 3/4, I just did the square root of 3 over the square root of 4, and that's how I got the square root of 3 over 2, because the square root of 4 is 2. Okay, right now you should be asking yourself about the reference angle. The cosine of what is radical 3 over 2? Forget about the plus or minus for a moment. The cosine of what is radical 3 over 2? Hopefully you are thinking pi over 6. So that tells us the reference angle. So the reference angle is pi over 6. So let's draw a diagram. Here's pi. Here's pi over 2. All right, not the prettiest drawing you've ever seen, but pi over 6. Here I've divided the numerator into 6 pieces. Now, the 4 angles that have a reference angle of pi over 6 are above and below the x-axis. So these are the 4 angles that have a reference angle of pi over 6. Now, the cosine of any of these angles is going to give me some type of radical 3 over 2. It's just that these two will be positive and these two will be negative. It goes positive and negative like that because cosine on the unit circle is the x value. X values are positive on the right, negative on the left. Now, we want solutions that are positive or negative, all right? We have plus or minus. So we want all 4 of these angles. We're going to have 4 solutions to this equation. So x is going to equal all of these. So this first one is pi over 6. So x equals pi over 6. The next one, all right, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6, 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So these are the 4 solutions to number 9. All right, let's check out number 10. All right, we need to get cosine 2 theta by itself. So I am simply going to add 1/2 to both sides of the equation. So far that's going to give me cosine 2 theta is equal to 1/2. Now, I cannot divide both sides by 2. This 2 is inside the trig function. You can't divide it away. So we're just going to solve for 2 theta. So the cosine of what is equal to 1/2. All right, hopefully you're thinking pi over 3. All right, the cosine of pi over 3 is equal to 1/2. That means whatever's in this position must have a value of pi over 3. Oh, well, okay, that's not totally true. Okay, what I mean to say is pi over 3 is the reference angle. So let me just slow down. All right, so the reference angle is pi over 3. We're not ready just to solve it just yet. So since the reference angle is pi over 3, let's draw a sketch showing those reference angles. So there's pi. If I divide this up into 3 pieces, that'll be pi over 3. Okay, so there are 4 angles that have a reference angle of pi over 3, above and below the x-axis. Okay, now the cosine of all of these will be some kind of 1/2. It's just that these two will be positive and these two will be negative 1/2. All right, cosine is the x value on the unit circle, so positive on the right, negative on the left. In this particular case, we want the cosine to be positive 1/2, so these two angles will be the solutions. Now remember, right now we're not solving for theta, not yet. At this point we're solving for 2 theta. So what we have discovered so far is that 2 theta is equal to pi over 3, which is this angle, or 2 theta is equal to this angle. Well, this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, so these are the 2 equations that will give me the solutions. Now and only now can I divide by 2 to get theta by itself. So I'm going to divide both sides by 2. When I divide a fraction by 2, I just put 2 in the denominator. Same thing over here. Divide both sides by 2. When I divide this fraction by 2, just put it in the denominator. You've divided by 2. So this is now going to give me theta is equal to pi over 6, or 5 pi over 6. So those are the 2 answers to number 10. All right, let's do a couple more. Number 11. Let's get sine 2x by itself. So I am going to add 1 to both sides. So that's going to give me radical 2 sine 2x is equal to 1. All right, so to get sine 2x by itself, I'm going to divide both sides by radical 2. That will cancel those out. Now I have sine 2x is equal to 1 over radical 2. Let's solve this for 2x. I cannot divide by 2 when it's inside the trig function. So I need to solve for 2x. So the sine of what is equal to 1 over radical 2? All right, hopefully you were just thinking pi over 4. All right, the sine of pi over 4 is equal to 1 over radical 2. So that tells us the reference angle is pi over 4. Now I like to draw myself a little diagram to help me visualize what's happening. So there's pi over 2, and here comes pi over 4. Okay, there are 4 angles that have a reference angle of pi over 4, above and below the x-axis. All 4 of these angles have a sine of some kind of 1 over radical 2. It's just that these 2 will be positive and these 2 will be negative. I know that these will be positive and these will be negative because sine is a y value on the unit circle, and y values are positive above the x-axis and negative below. In this case, we want the sine to be positive 1 over radical 2. So that means we will get the solutions here and here, those 2 angles. So remember that right now we are not solving for x. At this moment we are solving for 2x. But we have in fact discovered that 2x will equal either pi over 4 or 2x will equal, now this is 1 pi over 4, 2 pi over 4, 3 pi over 4. Now, if I want to get x, I need to now divide by 2. All right, I couldn't divide by 2 earlier. It would give me a totally different answer. Now is when you divide by 2. So I'm going to divide by 2 on both sides. When I divide a fraction by 2, I simply put it in the denominator. When I divide this fraction by 2, I simply put it in the denominator. So that is going to give me x is equal to pi over 8 or 3 pi over 8. So these are the two solutions to problem number 11. All right, that takes me to the 20-minute mark. So I'm going to go ahead and stop this video here. We still have several problems left to go. So these problems are coming up on the next video. So I hope you will join me, and I look forward to seeing you on the next video.